Welcome to Mastering Solutions. This is a general problem and they tell us to not solve the problem or to go over any math. They just want us to practice the concept of drawing the position and the velocity vectors to practice for later chapters when we actually will solve these problems. So let's draw the picture of what's going on. They say that a ball is rolling along a smooth horizontal floor. And then it starts up a 20-degree ramp, and they want to know how high that it goes before it stops and rolls back down. Obviously, we don't have to solve that part, but this right here is the 20-degree ramp. And so the ball is rolling along, and it's a smooth horizontal floor. So what they're trying to get at is that it's rolling, nothing is acting on the ball. So it should be going on a constant speed, and friction is not a factor since it's a smooth floor. So it's moving at the same speed. And then as it goes, it hits the ramp, and then it's going to be decelerating. So the arrows will progressively get shorter and shorter until we go to the very top, where it will stop. And then it obviously will start to roll back down. So there's essentially a few phases. One, we have this constant section right here where it's going along at the same speed. And then we have this second section here where it's decelerating. And then we could have other sections where it goes back down, where it accelerates down the ramp and then goes along at constant speed again. Obviously, we don't have to worry about that for the sake of this problem. And so here is the position diagram represented by the dots and the velocity vectors represented by the arrows for this question.